Okay. So here you can see this is the master node. This is the work. This is the data, right? This is the data. And from this data, this was the master node. Master node is having a total three worker nodes, and the data has been splitted with all three. Then we have total three partitions. All three partitions are distributed to three different worker nodes, and they are now independent data. They are working independently. That has been distributed, and now you are applying filter where age or greater than equal to 30. In this condition, based upon your transformation, this doesn't need the data to communicate with each other because logic is very simple. Simply filter where age is greater than equal to 30. Then from worker node 1, this Amit data got deleted. From worker node 2, this Amrita data got deleted. And from worker node 3, this Raj data got deleted. Only left records are Sunita, Rahul, and Sumit, the entire three. They are completely independent, no need to communicate with each other. That means here data shuffle will not happen. Data movement is not required. And that's why this is coming under narrow transformation. Narrow transformation means there will be the number of partitions and all the number of partitions are going to be work independently. There is no dependency, interdependency with each other. Okay, data is not required to move anywhere from one of the partition. Return, it will be returning again one of the output partition, one input partition, one output partition. This was the input partition with Amit and Sunita. This was the output partition, Sunita, out of this one. From worker node 2, Rahul and Amrita were partition number 2, and from out of this partition, this is the output, and from out of third partition, this is the output. Data movement is not required here because if you are trying to get the count also, this is the 1, 1 and 1. Finally, if you are trying to aggregate the data, aggregate the count, then 1 plus 1 plus 1. Here it needs to communicate because this needs, okay, what is the count here? So this is 1. Here again 1 and here again 1. So 1 plus 1, then 2 and 2 plus 1, 3. So when it needs to communicate with each other, then data shuffling will happen. And when not, then no data shuffle. No data shuffle means your processing would be very much faster because they are not going to communicate with each other, and that will be coming under narrow transformation. So this is the narrow one where the transformation logic is applied partition by partition, and the execution is straightforward because Spark knows exactly where the data resides. So about narrow transformation, as I already said in the interview, narrow transformation and wide transformation is the wide topic. Mostly, if you are not getting this question directly, this question can be the part of a Spark optimization. You may face the point what is the Spark optimization you have applied. That time you can talk about it, narrow transformation. Even you can give example if that is clear to you. So this narrow transformation, which is occurring when a single input partition contributes to a single output partition, as you already seen in the example, that means data dependency is localized. Localized means that is to the particular partition only. And there is no need to data movement because they are completely independent. No need to communicate with each other between the partitions across the cluster. And since there is no interdependency between the partitions, all tasks for a narrow transformation can execute independently and in parallel. And as this transformation logic is applied partition by partition, the execution is straightforward because Spark knows exactly where the data resides. Now these are some of the example. This is the map which applied a function to each element in the RDD or a data frame, returning a new RDD. Filter returns element that satisfy a condition. Just now we see we had given age is greater than equal to 30. So if that condition is satisfying, then it will be returning the data based upon that. Then flat maps. It is similar to map but allows producing multiple outputs elements per input. And then union. This is also one of the example, which is for combining two RDDs without duplicating elements in each partition. Now, here also you have one very basic interview question, map and flat map. Anyone has idea about this map and flat map? No, no issue. So
No.
map and flat map is again a question you can face in your Spark interview. Okay, question is simple. What is difference between map and flat map? So for that, first you have to understand about map. Means you what you can do, you can take up exercise for the map and separately for the flat map, and then you can see that perfectly what is exact difference between that. So at the high level, I can say for the map and flat map, both are the transformation options only, and narrow transformation in the PySpark, which is to process data in RDD, resilient distributed data set, and both functions apply a function to the element of an RDD, but output is different for both. When we apply map and when we apply flat map, the purpose for the map is applies a function to each element of the RDD, returning a new RDD where each input element corresponds to the exactly one output element, and the output RDD has same number of element as the input RDD. That is one thing. And we can say at a single line that when we want a one-to-one mapping between input and output, then we are going for the map. And when we talk about flat map, then this applies a function. This is for the flat map applies a function to each element of the RDD, and it will be again returning a new RDD where each input elements can produce 0, 1 or multiple output element. Means map is going to one, and this can be 0, 1 or multiple. This is not getting stick with the count. The output RDD can have a different number of elements, means more than, or it can be more or it can be few if you are comparing to the original one, previous RDD. And we can say that when we want to flatten nested structure, like splitting the strings into the words, then we are going for the flat map. Simply, I can run one other example before moving ahead, and you can note it down, okay? Because this will be part of your discussion. Most probably, it will be. If anyone is going to deep dive with a Spark, then this question can come to your plate. Okay, so I will first take Spark context from PySpark, import Spark context, and then SC equal to SC means Spark context, and let me take any random name. Let me take local, and then what is the any description? Let me take it map example. Just give me 1 minute, huh? Okay. So this is the map example just to test this. And then I will create one simple RDD. RDD equal to SC dot parallelize, and then let me take some numbers 1, 2, 3, 4, 5. This is one of the number. Okay, this is the list, and then applying a map function. Then I can say map.rdd equal to rdd dot map, and then using lambda function we can apply this lambda. Let me take x as a reference, and then I just want what I want, x into x, just multiplying numbers. Then finally print this, print map.dd dot collect. Then I will take the same for the flat map also. Then let's see what is the output. For flat map, I will do flatten map. Flat map RDD. RDD dot flat map. And then again we'll do lambda, and I will apply the same logic. Lambda, then take x, and for each x do x into x. Then finally print it. Print flat map RDD dot collect. Let's run this. We'll give this parenthesis. Let's run this. I can comment all this because this will be taking unnecessary times and errors. Okay, I should not have comment this Spark session. What is the error? Okay, SC equal to let me uncomment this. This is not required. This is Databricks, right? So it is one already we have created a Spark session, and there also is Spark session. Spark context is available, and here it is saying for the another instance. That's why the failure is. If you see here, this is 1, 4, 9, 16, and 25, and you see here just the output. Here it was having 1, 2, 3, 4, 5. Okay, and here it is having again with the same, and here it is having multiple. I think I can give one example with the words. This is not looking fine. So let me do this here. Let me create one data. Data equal to welcome to session. We are learning narrow transformation. We are learning narrow transformation. And then let's do data equal to this, and then RDD equal to SC dot parallelize, and then do data. And then words. Let just I will try to do a word count. Words RDD equal to or let me remove this as well. Let's make it simple. I will do map RDD. Map RDD equal to RDD dot map RDD dot map and then lambda and then let's say we have the lines. Then line dot split. Line dot split and let's take it with the space because here if you see the data, this is the separator and then just print it. Print result of map. Result of map. Map RDD dot collect. And again same if I do for flat map, then flat map RDD. RDD dot flat map. Flat map and then lambda. Then take the line for each of the line, do the split. Then line dot split and do this. Take the separator and then result for the flat map. Simply copy paste this. Flat map. And this is flat map RDD. Now print it. Go to the output. What is the map output and what is the flat map output? For map output, returning 1 to 1. In map also you had two lines, right? You can see this is the one of the list for one mapping and this is the second list for the second line mapping. This is just splitting based upon the space. Based upon lines, space, letters, character, however you want to split, you can. Now see the output for the flat map. This is completely different. This is not considering for the line by line, how it is considering for the map. Map means this is taking 1 to 1, but map, flat map, it can be fewer, it can be more. This can't be stick with the number of lines, number of input, exact input details. Okay, so this is the flat map where it has taken the complete data and it has tried to flatten that. So in any case, if we have kind of nested data, we want to do the flattening. And finally here if you want to do the let's say you want to do count, word count and all, then all the data each all together now in a single list. Now you are seeing anyways, as of now, I don't see any duplicate. So for all the things, the count will be one only. But let's assume that you have provided some duplicates, duplicate words which are occurring here. Then you can apply word count. Then it will be counting. Okay, what is the occurrence for each of the word, and for each of the word occurrence, this will be getting the count. So this will be the output for the map and flat map, and accordingly this is working internally. So you can explain in the same way if that question is coming to you. But you have to first do the exercise and be clear with the point. Then use case for the narrow transformation. Here, this is data cleaning and data transformation. This is for the specific transformation, of course. Where remove null or irrelevant values from a data set. If you have such a requirement, you can go for this transformation. Like for the example, we have a filter where you can say RDD dot filter and lambda x is not none something. Then data transformation, where you want to do some operations for changing the data, existing data, either that the data type, either formatting of the data or scaling the values, or maybe you want to do something else. Then you can apply the map. Like here we did, uh, just this is doing the multiplication with the numbers. What is the impact of narrow transformation? No shuffle. This is the main thing. Since each partition is processed independently, no network, input, output, or inter-node communication is required. That is not there. Fast execution. This is suitable for tasks with sample transformation and low computational overhead and resource efficiency. This requires less memory and CPU because there is no coordination needed any of the nodes. Okay, if you see this example, all are working independently. How many partitions are there? They are not working with any kind of dependency. They are completely independent. Whatever logic you are trying to apply, if that is narrow narrow one, then this is going to work on the same partition with the same node, so data shuffling is completely avoided. That's why it is going to make the process completely faster, and because of no shuffle, execution will be faster, and resources efficiency will also be there. Then you have next one, wide transformation. For wide transformation, this occurs when multiple input partitions contributes to multiple output partitions, and this involves shuffling. Where Spark redistribute the data across partitions in the cluster based upon the keys or other criteria. How it works. So during a wide transformation, data dependencies span across partitions, requiring Spark to sort, grouping, or redistributing the data. Shuffling involves serialization, network communication, and disk input output, which is making it computationally expensive. You can assume if data requires to move from one node to another node, then of course it will be expensive because this is going to take time, this is going to take the resources and everything because of the data movement and all. For the same example, if you take this, let's say this is the data again. Now you are trying for the wide transformation. This is the data you have distributed. Data is distributed internally. Now what you are applying? You are applying join, maybe self join, or if you have two data sets, then you can. Or maybe let's assume that you have worker node 4. You have one more worker node. You have worker node 4, and this worker node 4 contains data, something country and country code. Okay, like India or city. Let's say city, Mumbai, and some specific code for Mumbai is let's say 1, 2, 3. And then you have what all cities we have? Delhi, Mumbai, Kolkata, 3 cities. So let's say Mumbai, Delhi, and for Delhi, 4, 5, 6. Okay, and then you have one more record for Kolkata. Kolkata, and let's say 7, 8, 9. So this is the some this is some another partition, another data. Now you want to join this data with this data where based upon the city. City is common here, right? This is the city name and this is the code. Finally, you want the output with join and get output as name, name, and then age, and then city, then city code, something. In that case, this data contains a city name and city code. This data contains only name, age, and city. Then you are going to join the data, both the data based upon the city name, and then you can extract the city code, right? How you will be joining? You are applying a join condition. Let's assume that RDD1 join RDD2. I'm giving the simple syntax. Don't look at the exact syntax. This is not the right syntax, just a definition. I'm giving RDD1 join RDD2 based upon some condition, maybe column name. So based upon column city name, city name. How it will be working? Here also Delhi, Mumbai, Kolkata is available, and here at the same data this is available. Now this data, this needs to check out this data, right? And data shuffling will be happening, because of course if not, either these all data are moving here to check even what is the let's say here Delhi, Mumbai, it will be moving here to check out, okay, what is the code for the Delhi, what is the code for the Mumbai. This data also moving out, okay, what is the code for Kolkata, what is the code for Delhi. So either this data is moving to them all three to make sure that they are getting the city code, or these data are moving here to this data to this node and making sure that they extract the city code. Data movement will be there. Once data movement done, then finally they will be getting the final output. They will be having some intermediate output, and from the intermediate output they will be getting the final output in the map reduce phase internally. Anyways, in a Spark, map and reduce doesn't happen. uh, it is going to work with your in-memory process only based upon the possibility. If not possible, then again this is going to work with the disk efficiency. So likewise, this is going to work with by transformation, where based upon the transformation we have provided, data shuffling, data movement will be required, and that is going to make your job costly. This is costly because this is going to take lots of time. This is going to utilize lots of resources, and this will be costly in all the way because of this data movement. So this is occurring when multiple input partitions contribute to multiple output partitions, and as this is involving shuffling, because of this data will be redistributing the data. Data redistribution will happens, and as this is happening across the partitions in the cluster, whatever worker nodes is allocated for the data based upon the key criteria, like in the example we see for the city code for the city. So that is the key criteria, and based upon that data redistribution will happen, and it will be move out the data from one node to another node. How it works? During a wide transformation, data dependency span across the partitions that is requiring either this is just an example, either respect to sorting, grouping, or redistributing the data. Here is some example. Reduce by key, which is combining values for each key across partitions by applying a function. Then group by key, grouping all the values associated with the key into a single partition. For the group by key, you can see this one, that this is a very costly operation if you are applying anytime. This is going to always down your application because of its internal architecture, how it has been defined. So we should always try if we can avoid this. If it is not avoidable, then of course you have to use it. We can't ignore, but we can think if there is any alternative available, then we can choose that. Then join. This is the most operation which is requiring data shuffle of course at any cost until unless you are applying broadcasting. Of course, you have option for broadcasting where we can if we have a small data set, then we can make one copy available everywhere, and then data shuffle can be restricted. If we can see in the same example here, if we assume that this is a very small data set, then we can restrict these data to move out and check here either what country code is available or not, or what is the country code. We can do broadcasting. With broadcasting, it will be creating one copy of this data. So let's say it created three copy. One copy is available to this node, one copy is available to this node, and one copy is available to this node. In that case, they do not need to shuffle now to check what is the country code. At the same node, this data is also available, one copy is available. Simply they can check out there itself what is the code for this country. Okay, and they can get the output. So data shuffle can be avoided if we can plan for the broadcasting, but broadcasting can be only if data is small and it is fitable to memory. Then use case wise data aggregation. Summing sales revenue grouped by product category, and example you can say RDD dot group by lambda x and x plus y. I will take the same example and I will run because we have already created one RDD. Then data joining. Data joining combining the data. Let's say we are having a customer data, we have a transaction data. Then based upon the customer ID, we can do RDD1 dot join RDD2. Then data deduplication. If you have data which contains duplicate records and you want to remove that, then removing duplicate records from a data set can be done using RDD.distinct. These are just example. We are going to discuss about many more transformations one by one. What is the impact? Means how it is going to work internally. This requires a shuffle. Data is sent across the network, and that will be introducing the latency and high resource usage. Of course, if lots of uh, resources are means lots of shuffling is happening, data movement is happening, then most of the resources will be in use. High resource usage can be identified there, and that is because it is going to consume more memory, CPU, and network bandwidth due to a sorting and communication overhead for the data. Then complex execution. Whenever we are applying byte transformation, this often involves multiple stages, increasing execution time and fault recovery complexity. Okay, so if you see here, if we are talking about comparison between narrow and wide one, then for the narrow, each input partition maps to one output partition, and for the wide, multiple input partitions contributes to multiple outputs. For data dependency, this is localized within each of the partition, and for the wide transformation, this spans across the partitions requiring data shuffling. These are the common transformation: map, flat, map, filter, and all. And for the wide transformation, reduce by key, group by key, join, and distinct, just as above. We already seen in the document. Execution time. This is the main impact for the narrow and wide one. This is faster due to no shuffle. And for the wide transformation, this is slower because of shuffling and internode communication. Resources usage are low because it is avoiding network input output. There is no communication, there is no data movement, no shuffling. So resource usage are low. And here resource usage are high because this is doing the data shuffle. Data movement is happening between the nodes. Because of that, this requires lots of memory, CPU, and network usage. For the fault tolerant, this is very simple for the recovering the data or recomputing the data for a single partition, because here if you see the example, let's say this is having two records. In between, if something got failed, then this node, right, that this data was taken out of this partition. This already understand that there is no need to check with this partition and this partition, because this output is not dependent on this. This is dependent only on this one. This was created from this partition. So if any failure happens, then it will be recovering the data from this single partition only, and it knows that very well internally that where was the first stage, previous stage, and from where it has to recompute the data. So this is very simple recovery by recomputing a single partition. And this one will be complex due to multi-stage dependency. Wide one will be complex for the recovery because it is doing the joining, it is doing sorting the data, it is doing some another aggregation. In that case, there are multiple stages, not a single stage. And then it needs to know on which stage the failure happened and from where it has to recover the data. So for that particular thing, that will be complex. Then this is just a use case example, filtering invalid records and aggregating sales data by the region for the wide transformation. If we talk about scalability, then this is easily scalable as tasks are independent. And wide transformation, this is not scalable, but it requires, sorry, this is scalable again, but it requires cluster level coordination. Okay. So scalable is okay, but along with that, as it is going for the additional operations because of data shuffling and all, this is looking for cluster level coordination as well, and then only it can work perfectly. Here you can see for the performance, narrow transformation execute quickly and requires few resources. Wide transformation, it introduces significant overhead due to shuffling. For the scalability, narrow one works well even with the large data sets as well because tasks are isolated completely with the nodes. And wide transformation, this requires careful optimization to scale effectively. If you are not taking care, then your job is not organized well and your processing will be completely slow. Your job is going to take lots of time. And real world implications, if we see, then for the narrow one, this is ideal for retail tasks like cleaning and pre-processing the data. And wide transformation are used for complex analytics, aggregation, and combining data sets. Here, let's take this example. I will just copy paste. Okay. And then we will continue with that after your question if you have any. So here, let me just copy. This is narrow transformation. And then this is the output. This is wide transformation. And this is the this will be failing because of the space. Now let me run this. Okay. So if you see this, this is the output for this narrow one and this is for wide one. Narrow one, what we had given. Let me take this. A narrow one is the data. This is the name and this is data for the sales data. And this is just filtering greater than 4,000. Greater than 4,000 means that this 7,000 and 5,000. Rohan will be filtered out. If you check the output, Rohan is filtered out here. Only Amit and Priya is in the output. Now for the wide one. In wide one, we are looking for reduce by key, where we have some data and then for each of the data we have some value. Then reduce the value. North, it is having 7,000 and 5,000 based upon the key. Key is north. Okay, and this is the value. Value is 2 times, key is single for the single key. All two values got sum. So here it is 12,000. For south, this is a single occurrence only. If we have any more for the south, again that will be going with this logic, but this logic is not applicable because this is the single occurrence only. So this is still 3,000 itself. If you look at the output, this is same. North is 12,000, 7 plus 5, and this is 3,000. So like this is going to work with the map and flat map. Any question here from anyone? No? All good? What about you, Niharika? All are on mute and all are completely silent. Okay. I feel that all good. Any issue? What about you, Suleiman? You have any question? Nothing? Okay. But you people should speak. Hello, Naresh?
Yes.
Oh, at least you should speak. Otherwise, I will be getting that, okay, something is going wrong. Okay, fine then. I believe that you people have no question, then we can move ahead. So this is for the narrow and wide one, and just try to understand it and make a note how it is working internally and how it is different with each other. So you can go ahead with this if this is the part of your discussion in the interview. You can be confident with the options. Now here I have listed some transformation for the narrow and wide both separately. We are going to discuss that one by one. Okay. Uh, because in interview again, you can have the questions what all transformations you have used in your project. Let's say you are mentioning some 3 to 5 projects in your resume. All the projects can't have the same business logic, right? All will be having some different use cases, different business requirement. In that case, of course, there will be some common transformation and some unique also can be there. I have seen in the real time most of the people like with the option itself. They are saying that they have worked with 4 or 5 projects, but they are unable to explain what they actually did. So if you are practicing some 10 to 20 transformation, not needed to explain all this, you can be sure for at least 15 to 20, or I can say 10 to 15. 15 is max, and that is enough. You can take up that and you can talk about that in some of the project these are the transformations you have used, and in another project these are the transformations either that was common with the previous one or that was unique with the previous one. So you can talk about that at least 5-10 transformation. I have seen, as per my experience in the interview, I have seen that people are not good to explain, not explain, only even naming the transformation for the more than 4 and 5. That means very simple. Either they did only copy paste the entire day, they did not focus anywhere, so they don't know, or they didn't do anything. They're just mentioning that they have did in the resume. So both options can be there. So you can be little bit active here, and you can make sure that at least you are having confident with some topics, at least 10-20 names, and what these are doing, how these are doing, you can explain that. So here we have map, flat map, filter, distinct, sample and all. So let's go one by one how this is working. I will simply copying all this thing. I will copy 10 only as of now, not all. So here I will create one new, and let me give narrow transformation. Narrow transformation, and here I can go with this. So these are first 10 transformation. If you go with all this, let me first comment this. Just comment this, and then I can go for the map. If I go for the map, just we had discussed about map and flat map, right? So we can take it, and again I have already taken this here. So for this narrow and wide transformation, let me copy this. I have taken for first 10. Okay, so if you see, this is the Spark session for narrow transformation, and I'm taking this Spark context. Then first RDD. Using RDD, just using the parallelize, creating this RDD and applying lambda x multiplying by 2 and then collect. Then just running for this map result, and this will be 2, 4, 6, 8, 10, because this is simply doing multiplication. And then when I'm doing flat map, this is similar to map but flatten the result. Okay. For the map, if you see, applies a function to each element in the RDD or the data set. Here I am applying the logic flat map, and it is doing the split and then collect, and finally collecting the map flat map result. Now you tell me what will be output for this flat map result based upon the previous exercise. What it will be? Any idea? This is the
So
input learning is part.
learning Spark,
Mhm.
Spark RDD and flat map. It's a flatted format.
With the single or a multiple list.
Single.
Let's run this. I think resources. It is available. So this is learning Spark, Spark RDD and flat map. So this is for the flat map. Then we have next narrow transformation. This is the filter. If we look at it, then again 1, 2, 3, 4, 5. This is your input data and doing the filter. Just trying to filter x is divided by 2, and that is equal to 0. If so, then collect the output. Here, if you try to divide, 2 will be, if you are dividing the 2, that will be satisfying this condition. 4 is also okay. 1, 3, and 5 is not divisible by 2, right? If we are doing the filter, if we are applying the filter with with this data, then we will be getting the output accordingly. So like this, you can apply the filter with the RDD. But again, these transformations I have did over the RDD, not with the data frame or data set. In your exercise, you can include to do this with data frame and data set both. Like you have a data frame and you have some data. Let's say employees data are there based upon the employee age or based upon the employee joining date or based upon the employee location. You can apply the filter. You can do the filter. Here, this is filtering the result 2 and 4. That is divisible by 2 and answer is 0. It is coming equal to 0. Then next transformation we have distinct. What is for distinct? Distinct is for what distinct does?
Um,
Remove duplicate values.
This is same as your SQL, okay? So this is going to remove the duplicate elements within each partition. Each partition, why? Because we are talking about narrow transformation, right? And narrow transformation works for each of the partition. This is not going to work with all the partitions altogether. All will be getting workout, but one on one. There is no communication, no connectivity with each other. So from each of the partition, this will be removing the duplicate. Like, let's say for this example, this Amit was available here also and here also, and this Amit was available here also. In that case, if that is going for the distinct for partition by partition, then this will be getting removed from for each of the partition. Again, if you compare with the another partition, it can be duplicate. Maybe Amit is available to another nodes also. So if further you are applying where that data needs to communicate with each other, and then it will be working with dependency. If single node, then there will not be any dependency. So for this distinct, let's say we have 1, 2, 2, 3, 4, 5, 5 something. Then this data gets distributed over the nodes, and then you are applying dot distinct. You can focus on this syntax itself. Syntax are really very simple in PySpark. There is no complexity, and most thing is if you type this one time from your hand, do not copy paste simply. If you are doing the copy paste, then you will not be remembering this. Very simple. Maybe you can check the input, you can check the output, you can complete your exercise, but this is not going to help because copy paste is always not good. Sometimes it is okay if you already know this. If you are new, then recommendation is to type this, don't copy paste. So you can see here rdd.distinct and then collect. If you are doing the distinct result, then it will be coming with the distinct one after removing all the duplicates. So here if you see, now distinct result is this 18192 103. There is no duplicate, but what do you see here? Something which could have been more better. Do you see something?
sorting, sorting order.
Right. This is coming in the random order because this was working with one node. There is no data shuffle because, and if there is no data shuffle, then of course this data will not get sorted because in which order data was received to the driver node in the same order, this is printing the output. Now if you want to sort the data, then you can apply sorting on top of this. But what will happen then? Sorting means then data shuffle will happen. Data will that is aggregation, right? Data needs to know about each other. There will be dependency. Okay, this is 1 and 2. What's next? Suppose next random is 5, but you need after 1 and 2 you need 3, and then you need 4, and finally you need 5. Not in between. In that case, this needs to look out, okay, where is 4, where is 3, something like that. Then doing the sorting. Then data movement will be their data communicate because they are not independent now. They are dependent. They need to know about each other. Then if you are applying the sorting, then that will happen. But here this is not sorted. Then this one is the sampling. If you see the samples a fraction of data for from each partition. Sampling means, let's say you have GB and TB of the data. You want to check about that. You want to take some samples. If you are trying to print the entire data, get the whole data, what will happen? This will be costly process, right? Because if you have good amount of data, then all amount of data needs to take more resources for processing, for getting the output. For getting the output, it needs some more resources again for the memory utilization and all. If you want just for the testing, you can take the sampling a fraction. Where let's say this is your RDD 1, 2, 3, 4, 5, 6, and you want some sample. You can go with this. These are the parameters for the sample. Okay. If you look at this, here you can see the definition, how this has been defined. Def sample, then with replacement. If you want some replacement for the same, then boolean, either true or false. Then fraction, float, you can provide what is the percent, and then seed, either none or maybe you wanted to provide something. Then this will be providing, this will be returning with the output. Here you can see implementation parameters here down in the same. With replacement bool can element be sampled multiple times, and fraction float expected size of the sample as a fraction of this RDD size without replacement. Probability that each element is chosen, and fraction must be 0 or 1, 0 and 1. Then with replacement, that is the third parameter, and expected number of times each element is chosen. Fraction must be greater than equal to 0. And then seed. Okay, seed is the final parameter here. Where this is talking about integer and optional. This is the optional one. Seed for the random number generator. Okay. So here these are the parameter for this. If you are doing the sampling for this data, what will be? So let me do this 2 times. One is for 0.3 and one is for 0.2. So sample result 1. And let me do this one also. And here let's take 0.2. First run, let me run with the same acid. Then we can check out with the difference as well. This is taking same output, no differences. Anyways, we have very much small data. Data should be bit larger. 7, 8, 9, 12, 13, 14, and 15. Actually, this try to take the sampling in the with a random number. Okay, still this is taking the same. And if I do this 50. There is no difference. We see the difference if we have good data, but here I am unable to.
Okay. Yeah.
Sorry.
Why I was talking about fraction value.
Fraction value, it is
Only
different, right? This is 0.3, this is 0.2. Let's say I'm
but minimum
saying,
difference we can make it. Yeah, there is a minimum difference, 0.2 and 3. Yeah,
still same. Okay, I'm just thinking how this will be taking the difference. This is not taking. Anyways, you can try out with the big data. Okay, good amount of data. Then this will be having that. This is Just for
Actually,
taking sampling.
in the sample result too, where we are printing, we are just taking sample result on.
Okay, this is the problem. Yeah, good catch. So small things happen sometimes, and this is a good debugging skill, right? This should be good in debugging. Then let me do this again with 0.2, and let's take this 25 only. Okay. Then with this, as differences is very much similar, means with the same data. Let's take 2.0 with the seed option same. With 25, yeah, we can see the differences too. So this is just to take the sample, how much you want. Okay. Then this is so this is helpful whenever you have good amount of data. Let's say you are having thousands of the lines, millions and billions lines are there, and you want to take some sample for let's say some 0.1% or 0.01% something, and what kind of data is inside the file or inside whatever distribution happens for the data, you can go with that. So this is just for sampling, which will be help you to catch quickly, and then accordingly you can have your further steps. Then you have union. I believe that union you have worked in the SQL. Anyone has worked? In SQL, did you get any chance to combine two outputs? Or let's say for one of the query you are doing some different joins, for another query you are doing some different joins, and finally you want to merge both of the output. Any opportunity to get that kind of output or details? No? Okay, not an issue. So here in SQL, if you have no opportunity till now, then try to do some exercise with SQL as well. Okay. So this is union which is used to combine two RDDs or data sets without shuffling. And this again falls under wide transformation. I have mentioned, I have copied for the narrow only, but let me see here. 6. Okay, this is in the same sequence. So this is for the wide transformation, and then for RDD1, this is 1 and 2. For RDD2, this is 3, 4 and 5. Now want to do the union RDD2. What will be output here?
1 to 5, 1, 2, 3, 4, 5.
Okay. If you will do with the data frame, then use case will be a bit different. This is RDD. Okay. So RDD is not having any column and all. So you are okay. This is just a sample data and this is doing union 1, 2, 3, 4, 5. Let's assume that this was a data frame. Then data frame is having the column names. While union, you have to clarify that what you need actually while you are doing the union. You need to merge the row. And then while merging the records, both of the result set should have same column name, right?
Yeah, same
Then
schema.
then only you will be able to merge that. So this use case will be a bit different if you are applying the same with the data frame. So whenever you are doing the exercise anyways, when I will be sharing the exercise, then I will share for the RDD and data frame both. So you go with both one, then only you will be having the clear understanding. Otherwise, again, maybe with the RDD you are very much okay that okay this is going to combine the both, but this is not the same similar in the data frame. In data frame, let's say one data frame is having two columns and another data frame is having three columns, one column more. Then again you will be having some challenges, or maybe both are having two columns only, but the schema is completely different. Then again, you are having some different challenges. So you have to make sure that it is good and it is working fine as per expected. If not, then how? What alternative you can apply and you can make it work out. Then map partition. So this union is a very much required transformation, and we use it. In the project, I can't say 100% in all the project, but of course, probability you can see for the 50%, 40 to 50%, because most of the time we need to merge the data and we need to get it. Then we have map partitions. Map partitions applies a function to each of the partition. If we are creating the normal RDD, if you see here RDD1, what we did, SC dot parallelize and 1 and 2. This is the element for the RDD. Here I am applying 2. What is 2 here? So if you go to this 2, you can see parameters, num slice, number of the slice, the number of partitions for the new RDD. Means by default, if you are creating any of the RDD, how many partitions will be there? Any guess? Any idea? Let's say you are submitting 1 GB of the file or 200 MB of file. By default, how many partitions will be there? Or how logically it will be? It will be. So
By
logically,
default, three partition,
sorry.
three partition by default.
So by default, based upon the internal block size, if we are relating with Hadoop, it will be creating the partitions, right? It can be let's say 128 MB or 256 MB something. Based upon the configuration, this is going to create. But if you want to have some particular number of partitions, in that case, you can give here 2. If you are saying 2, that means your data is having this much specific partition. Then map partition result, you are doing something. So here I have once I gave 2, that means my RDD is having 2 partitions. Then map partitions and partition, then I am doing the sum and then I am doing the collect. So for let's check this. Print print RDD RDD dot get get num partitions. Get num partitions. Let me first see if this is working. Num partitions 2, right? Then I will be taking the by default one. Here, let me take uh, this. Let me remove this. Then let me take the num partition. See, by default, based upon its internal process, based upon its own logic, by default, this is going with 8 partitions. Okay. If we want to restrict, we do not want to go with the Spark one. How is Spark is taking care internally? Forget that. We want our own because based upon the partitions, we can have a good control over the flow. Then we can provide the number of partitions. So here, providing the number of partitions. Let's say as of now, partition number is 2. Then partition is true. Finally, map partitions result for each of the partition, doing the partitions and then collect. Then if we run this, it is saying 6 and 15. How it is coming for 6 and 15? This data is getting divided into 2 parts. One part is having 1, 2, and 3, and second part is having 4, 5, and 6. So if you see 1 plus 2, 2 plus 3, it will be 6, right? And 4 plus 5 plus 6 will be, what will be the count? 4 plus 5, 9, 9 plus 6, 15. Like that. Here, if we take, I will simply remove some. Let me run this. This syntax is wrong. I wanted to do something, let it be. Okay, so this is going to work like this. If here, if you see the output, this output is not all together, right? Output is coming with anyway. This was for the failed output. This is 6 and 15. I will simply print RDD, RDD. RDD dot select. Okay, spelling mistake. Now, if I come here, this is the RDD 1, 2, 3, 4, 5, 6. Okay. So if I do here you can see the output 6 and 15. This is because you have 2 partitions. If I remove this 2 partition, let me take 3. Partition is 3. Then what will be the expected output? You can tell me. If I do this map partitions 3, then what will be the output for this?
It's 7 and 11.
Okay, so this data will be redistributed for based upon the number of partition, right? And then for each of the partition, this will be getting the output. Yeah, so this is 3, 7, and 11. So likewise, this will be working, but again, this is then this is working for each of the partition. This is not working for all of the partitions, so its output will be for the individual one, not for the altogether data. Finally, if you are applying the sum, or if you want to do something with the data, again you can do the mapping and you can do whatever you want to. Then we have for each. This is something you can use in your project. We use it in most of the use cases, where for each executes a function on each of the element without returning a new RDD. What you have learned in the previous one, that is returning a new RDD from the previous one, right? because of immutability. Here you are simply trying to work with the same RDD. You are not looking for returning a new RDD. So on the same RDD you are saying for each and then doing the print. Then it will be taking for the from the same RDD. It will be for each of the element. This is going to print it, but this is not going to return on new RDD. So this is for that is for the for each. Always in the real time we have to limit the use case for this because sometimes it can kill the performance of the job and okay. So this is not printing. So let me thing wrong.
Print X is
No, that
okay.
will not. It is not working with this. So let me take this one. This is for recording RDD.collect. This is the simple one. Okay. So it should work, but I'm not sure why this is not taking up. But again, I'm taking lambda. Let me take like this, where I can say for number in RDD dot collect and then print number. This is also a loop only, right? Where for each of the number we are looking for print.
And the 2 is missing in print.
Okay. One, two, three, four, five. Anyways, previous syntax also should work, but maybe that needs some additional step as of now here. Otherwise, this syntax wise it is okay. Where you can apply for each. Okay. Now come to the next. This is zip. This is something you are going to use a lot in your real-time project for most of the use cases. Again, this you can apply with the RDD also with data frame also. This is for combining two RDDs into a single RDD by pairing the elements. And again, this is the part of white transformation I have mentioned here. So let's say we have RDD1 where we have 1, 2, 3, 4, and we have RDD2, A, B, and C, D. Then result wise, what we are looking for? We are looking to zip the data. RDD1 dot zip and RDD2. Then if you are zipping the data, then how it is getting combined? Because you have some union. Union is working in a different way. How it is merging the data all together. But if you look out for the zip, what it does, it took the data set from both. And A1 is coming with the A2 is coming with the B3 is coming with the C. This is coming in sequence, right? If you break this sequence here, this will be working in the same way because this doesn't understand what is A, B, C, D and all. Whatever you are providing, this will be taking accordingly. Again, 4 is mapped with A. So in the same sequence from the RDD1 and RDD2, this is zipping that. We can zip, we have zip with index, we have zip that we can try out with the RDDs and data from data sets all. So you can
The
include
number of
that.
items is different in that.
Sorry?
RDD1 there are 4 items, and if we
Uh,
put more than
oh,
4
let's
items.
do that. Try out anything, whatever you are looking for. See what happened and see the error. Can only. This is the Spark exception. It is not completely clear. Here you can go and you can see. This is giving you the
Number of
detail.
items are now.
Correct.
Like union, we need
So,
to same.
sorry.
It works like union, so both the
Correct.
RDDs,
So
it should
mapping,
have the
mapping,
same number of
mapping should be
items.
fine. Mapping should be
Yeah.
fine. Otherwise, this is unable to map. This is not getting the pair for this.
Yeah.
Okay, that's why. Okay, so let's stop here itself. We will discuss the next one tomorrow. You have any question for this one?
No.
Okay, fine then. Make a note of whatever I discussed that can be the part of interview. Okay, related to transformation, arrow, wide, and all. And then whatever we discussed, I will be sharing the exercise for RDDs and data frame both. You can do that exercise. And the rest, whatever issues you are facing, try to run with another IDE as well and see if it is still same. Because some issue is with your configuration only, Spark setup,
Yeah.
nothing else. If that is okay, then it will be working fine.
Okay.
Okay, then let's meet tomorrow for the next part. Okay, have a good day. Bye.
Thank you.